Hello, I am Tanisha Bhattacharya, a fourth year student of BTech in Computer Science and Engineering from Adams University. In this video, I am going to demonstrate my minor project, that is diabetes detection using advanced computing techniques, which is done under the supervision of respected Professor Mr. Kaushik Datta, Department of Computer Science and Engineering. So now, why have I chosen this project? That is, why have I chosen diabetes detection? It is because it is a very common, popular medical condition that affects millions of people nowadays due to the lifestyle, due to genetics, maybe any reason. If it is not diagnosed at an early stage, then it may lead to heart strokes, kidney diseases, eyesight loss, and detecting it at an early stage is very difficult using medical techniques. So here I have proposed some machine learning and deep learning algorithms to predict diabetes at an early stage. For this, I have used the PIMA Indian dataset consisting of data of 768 PIMA Indian females and 8 attributes. Let us have a look at the dataset. Hmm. So if I look at the dataset, it is something like this. So it has features like pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, and age. And outcome is 1 or 0, that is 1 means presence of diabetes and 0 means absence of diabetes. So I have applied three algorithms, two machine learning algorithms, that is SVM and random forest, and one deep learning algorithm, that is artificial neural network. So let us have a look at SVM first, that is support vector machine. So I have already uploaded the data, so that is d2.csv. Then I am running this cell to have a closer look at the dataset. So SVM is a popular machine learning algorithm for classification. So here you can see this features, and then so I had tried to apply this feature selection techniques such as entropy and information gain, and obtain the two most prominent features as glucose and age, which mostly affect diabetes, which mostly influence diabetes. That is, if the age is high and if his glucose level is high, will have a higher risk of diabetes. And then the other less important features are skin thickness and pregnancies, like that. And first I have applied SVM on the whole data set. So let's run it and see the accuracy. It gives an accuracy of 79.22%, which isn't that bad. And this is the confusion matrix. And then I applied it on four features. That is your age, glucose, skin thickness, and pregnancy. So if I run it, it is given accuracy of 77.27%, which is not as good as that it was giving when applied on the whole data set, but it's okay. Then I am applying it on two features, that is glucose and age. Let's see what accuracy it gives. 77.92, almost similar. So from this we can conclude that SVM performs the best when applied on the whole data set, in this case only, in the case of this PIMA Indian data set only, which gives us an overall accuracy of 79.22%. So now let's go on to random forest, which is a machine learning algorithm like SVM only. It can be used for both classification and regression, but we are using for classification in this case. So I've already uploaded this dataset, diabetes.csv. Let us run this cell to have a closer look at the data set. Yeah, then let us run the individual cells. So here I am specifically visualizing the x and y. That is, x is the all the features and y is the outcome. So then it's y is equal to df outcome. So I am initializing y. Then in this cell I am basically training and testing. So I am considering 70% of the data set for training and 30% for testing for all the three algorithms. Let us learn this. I am fitting the data set using scaling the data set more better using standard scaler, and then I am running this cell with the net output. I am using this random forest classifier from sklearn.ensemble. So if I run this, it gives an accuracy of 78.57%, close to that of SVM, which was giving 79.22% when applied on the whole data set. So now let's move on to NN. So artificial neural network, as you all know, is a deep learning algorithm. So it works best on images. It also works on CSV datasets. So let me run this. Okay, now close the loop to the dataset, initializing the X and Y, training and testing, scaling. Then I add use scalars to implement ANN. Basically, so first I am just building a model, so using sequential, and then adding the layers, that is the input output layers. So at last I compiled the model, and then if I run it now, yeah, this is this model summary. So I am trying to now fit the model, change the model, that is X train, Y train, and epochs is 2500 and batch size is 15. So when validating, that is testing it on X test and Y test. So let's run this. So we have finished running the NN. The epochs were 2500. So let's now save the model. Now run it and load the model. Model 1 is the model name. So in form now keras.models, I am loading the model by using load underscore model. So again the model summary is visible. Now if I come to this, if I run this, I will get the accuracy. So it is basically using F1's code, recall, precision, and accuracy, all the functions I get it. So then I plot a confusion matrix. So I get here 72.72%, which is very less. Which is the least, I think, compared to all this. So yeah. Intent does not perform well when applied on CSV dataset in this case, in particularly this case. So these three algorithms, so using the three algorithms, I can draw to a conclusion that the most efficient was SVM when applied to the whole data set. The least efficient was ANN. Random forest was also efficient, but not as much as SVM. It outperformed all of the other algorithms. So in the future, I can make a big data set. I can use other data sets. I can make my own data set by conducting surveys under medical supervision. and can apply a better version of deep learning algorithms like convolutional neural network, like recurrent neural networks. So, thank you.